Today, we are reviewing the instructional guide, Automate the Boring Stuff with Python, a text aimed at teaching non-programmers how to write code to handle, repetitive computer tasks.
And the source material is just exceptionally strong, highly successful, and honestly, perfectly hits its target demographic right out of the gate.
Right, which is why this critique will focus purely on high-level opportunities to elevate the reader's long-term success with the material. So let's dive right into the first area for improvement.
Let's do it.
The strict division between foundational programming concepts in the first half of the material and practical automation tasks in the second risks losing the reader's engagement before they reach the text's core promise.
Yeah, that's exactly it. Because the text brilliantly promises to turn the reader's computer into like a Swiss Army knife to avoid boring chores.
Right. But then Part I spends all these chapters covering abstract syntax, loops, lists, and dictionaries using these very classic game-like examples.
Yeah, utilizing examples like a tic-tac-toe board or, Conway's Game of Life to teach data structures creates a huge disconnect.
It really does. I mean, the reader is here to automate office work, not to build text-based games.
Exactly. If I'm an accountant, I'm trying to manipulate an Excel spreadsheet. I'm not trying to build a fantasy game inventory. This means the actual automation payoff is delayed until Chapter 7 or later.
Which is a long time to wait. You're asking a beginner to hold all this abstract logic in their head without any real-world reward. Think about the Pig Latin translator example.
Oh yeah. The cognitive load there is intense. Right, because to write that script, the reader has to juggle two totally different frameworks. First, the actual Python string slicing rules.
And second, the arbitrary phonetic rules of Pig Latin, like how to handle consonant clusters versus vowels.
Exactly. So my suggestion here is to integrate micro-automation tasks directly into the foundational chapters to provide an immediate practical payoff that aligns with the audience's primary motivation.
I love that. Give them a quick win. What does that look like in practice? Say for that string manipulation chapter.
So instead of translating text into Pig Latin, have the reader write a script that standardizes a really messy list of client phone numbers.
Oh, that's good.
It teaches the exact same mechanics, right? You still iterate over a string, slice out the area codes, and concatenate them back together.
But the output is a clean database column that they can actually use at work the next morning. It's not just nonsense words.
Yes, precisely. And we can do the exact same thing when teaching dictionaries in Chapter 5.
Right. Instead of using a fantasy game inventory where you map like the string arrows to the integer 12.
Or a tic-tac-toe board.
Yeah, exactly. Instead of that, you demonstrate how a dictionary can be used to count the frequencies of specific words in a messy, copy-pasted email.
It uses the exact same 5 lines of Python to check if a key exists and increase its value. But suddenly it's relevant to a corporate environment.
Now, to be fair to the author, there is a narrative through line here. They actively explain their approach using that Sudoku analogy.
Right. The idea that you have to learn the rules before you can play the game.
Stick to tradition if the audience isn't traditional.
That's a great point. They are time-strapped office workers, not four-year computer science students.
Right, so by blending those blocks with micro payoffs, you keep their momentum going. Every new syntax rule should demonstrably shave, 5 minutes off their workday.
But getting them into actual automation early brings up a whole new set of challenges, which naturally leads us to our second critique.
Oh, definitely.
By explicitly trading away best practices and robust error handling for the sake of simplicity, the material inadvertently sets the reader up to build fragile tools that may break under real-world conditions.
This is such a fascinating tension in the text, because honestly, lowering the barrier to entry by encouraging throwaway code is a great hook.
It totally is. Admitting to using global variables just to avoid complex topics like object-oriented programming is a huge relief for a total beginner.
Right, but that becomes a severe liability in the later chapters, especially when we get to GUI automation, controlling the mouse and keyboard.
Oh man, yeah. GUI automation is dangerous if you aren't careful.
If a script relies blindly on hard-coded screen coordinates, like telling the mouse to click exactly at X500 and Y300,
The moment a website updates its UI or an Excel sheet shifts by literally one row, the script will misclick.
exactly. And the potential for disastrous errors for an office worker is huge. You don't want a script accidentally clicking delete instead of save.
Or sending a confidential report to the wrong client.
Yes. So, my suggestion is to introduce the concept of script resiliency and basic defensive programming early on, teaching the reader how to make their code durable without forcing them to learn full object-oriented programming.
So how do we do that without overwhelming them? Give me a concrete example for that GUI chapter.
Simple. Heavily prioritize teaching PyAutoGUI's locate on screen function. Teach the image recognition features before ever teaching hard-coded X and Y coordinate clicking.
Oh, because locate on screen actually looks for the visual pattern of, say, a submit button, regardless of where it is on the monitor.
Exactly. Hard-coded coordinates are like telling a blindfolded person to take 5 steps and reach out. If the target moved an inch, they miss. Image recognition takes the blindfold off.
That's a perfect analogy. And we can apply that same resiliency concept to the web scraping chapter, right?
Oh, absolutely. If a script tries to scrape data from a web page that's loading slowly because of a bad network connection, it'll crash.
Because the HTML element doesn't exist yet.
Right. So include a concrete example of how to implement a timeout, or just check if an HTML element actually exists before trying to interact with it.
Just teaching them time.sleep changes everything.
Now, I know the constraint here. The author is actively trying to avoid adding complex concepts like classes or generators to keep it accessible.
And I completely agree with that constraint. But think about it like teaching someone to drive. We don't need to teach them how to build a heavily armored tank.
Right.
But we should at least teach them how to put on a seatbelt. That's a great way to put it. Resiliency isn't advanced computer science. It's just practical self-defense for automation.
Exactly. And, if scripts do break, and they will break, the reader needs to know how to fix them.
Which segues perfectly into our final focus area. Relegating the dedicated discussion on debugging to the midpoint of the material delays the development of the most critical skill a new programmer needs, the ability to independently fix broken code.
This is maybe the biggest structural flaw for me. The text places the debugging chapter roughly around chapter 10 or 11, depending on the edition.
Right before they transition to web scraping and spreadsheets.
But beginners are going to encounter exceptions, syntax errors, and logic bugs the literal second they start writing while loops and if statements back in chapters 2 and 3.
Oh, absolutely. The first time they forget a colon, Python is going to yell at them.
And by withholding the tools to decode tracebacks or use logging and assertions until the halfway mark, the reader is left highly vulnerable to frustration.
They just see a giant wall of scary red text and think they broke their computer. It leads to them just abandoning the project entirely.
Exactly. So the suggestion here is structural. Pull the core philosophy of debugging and the specific tools required to do it forward into part 1.
Treating error resolution as a fundamental, normalized part of the daily programming cycle rather than an isolated task.
Yes, precisely.
So what does that look like in Chapter 1?
Well, when you introduce the print function in Chapter 1, don't just teach it as a way to say, hello world. Teach it explicitly as a primitive debugging tool to peek inside variables.
Oh, I like that. Showing them that they can actually look inside the machine's memory at any given time.
Exactly. And then, for Chapter 2, add a dedicated section on how to read a traceback.
Because that red text is so intimidating.
It really is. Demystify it for them. Show them exactly where to look for the line number and the error type, so when they inevitably misspell a variable, they know how to find it.
Now, I can see why the author put it later. Perhaps they thought discussing crashes and errors right out of the gate might intimidate the reader, ruin the magic of automation.
I get that logic, but we need to reframe debugging as an exercise in empathy for the reader.
Empathy? How so?
Errors are inevitable. By hiding the debugging tools, we actually increase their anxiety when they hit a bug. They think it's their fault.
Oh, I see. Normalizing bugs early on actually empowers them, like leaning into the text's own joke that debugging is 90% of programming.
Exactly. Tell them, hey, professionals do this all day long. You didn't break anything. This is just how you code.
That's a massive confidence booster. All right, well, let's briefly recap our core analysis today.
Sounds good.
The material is a brilliant, empowering text for non-programmers. To make it even more impactful, the author should, first, integrate practical micro-automation tasks into the early syntax chapters.
Right. Ditch the pig Latin and standardize some phone numbers.
Exactly. Second, introduce basic script resiliency to prevent fragile code, especially relying on image recognition over hard-coded coordinates in GUI automation.
Gotta have that seatbelt.
Yep, give them the flashlight before sending them into the dark.
Well said. We want to genuinely thank the listener for submitting such an incredible and widely loved piece of work.
It really was a pleasure to read.
It was, and we enthusiastically invite you to implement these structural adjustments and submit your revised material back to us for another critique. We'd love to see where you take it.
Keep up the fantastic work.
Until next time, keep writing, keep coding, and we'll catch you on the next critique.